And a within subjects ANOVA is the paired version of a between subjects ANOVA. Usually we have multiple time points with the same subjects. This is called a repeated measures design. Here, for example, we have 3 time points and 4 subjects. And this is repeated measures because you can see the subject takes the assessment 3 times. So subject 1 at time point 1 had a score of 2. Subject 1 at time point 2 had a score of 8. And subject 1 at time 3 had a score of 3. So you can see it's repeated. So here, for this kind of data, we would need to do it within subjects ANOVA. And the reasons is 1, we have 3 groups. So we can't do a t-test. And then we have pairing or repeated measures. So that's why we need to do it within subjects ANOVA. And you can see they're paired by subject. So all this data is paired together. All this data is paired together. All this data is paired together. And all this data is paired together. Okay? And down here I have dots to represent the data. So in blue we have time point 1, in orange we have time point 2, and green we have time point 3. And then on the dots we have numbers to represent their subject IDs. So you can see that time point 1, the data for that, the scores for that tend to be sort of low, and then for time point 2 they tend to be sort of in the middle, and for time point 3 they tend to be the highest. But you can also see that there's something going on with the subjects. So you can see subject 1 here, so here and here and here, they tend to be lower than the other people for each time point. And then subject 2 tends to be in the middle, and subject 3 tends to be at the top, and subject 4 tends to be in the middle as well, just like subject 2. Oh, and here's 3 too. 3 tends to be at the top. And so you can see there's some kind of variability that we can account for based on the subject. So within subjects ANOVA we can take advantage of that and remove the variability that's due to the subject. So maybe this is an achievement score and subject 3 is really smart, maybe, and they tend to score higher than everyone else, and it doesn't really depend on the time point. And subject 1 might not be as smart as the others, so they tend to score lower than the other subjects. And we want to remove this kind of variability. It's kind of makes the f-test kind of fuzzy if we don't account for this. What we want to know for the within subjects ANOVA, the question that we're answering is, do the assessment scores vary by time point? That's what we want to know. And we want to remove the variability or the noise from subjects. Or you can, in other words, remove individual differences. And this makes, in most cases, our F statistic more powerful. But not always, because the degrees of freedom will change a little bit. Okay. So I'm just going to try to draw for you the between time points and the within time points. So this is just like a between subjects ANOVA. We haven't gotten into anything new yet. So the between, so first let's get the averages for each sample. So for sample, for time point 1, we would have a mean of 4. For time point 2, we have a mean of 10.5. Oops, wrong color. And for time point 3, we have a mean of 10. And then our grand mean, you can put in white, is 9.5. So if you add them all together, you'll get 9.5. And if you do it for each time point, you'll get 4, 10.5, and 14. Okay, so the between variance. So let's just focus on this person and this observation. So this is person 1 at 10.1, and they got a 2. So some of this variability for the score is accounted for by the sample mean, and some of it is not, because it's not right on the sample mean. So the total variability from the grand mean is this distance. So this is the total variability. Or this much of it, a good portion of it, is explained by the between time points variability, or TB. And what's left over here, this part, that is the within variability. So that is the within time point variability. And so this should be kind of a review. And so if the between variability on average for each of the observations tends to be more than the within variability, then we'll have a significant F-test. But what we can do is kind of cut out some of this within variability and take out some of it that's due to the subject. So part of this variability here is due to the subjects, and some of them tend to score higher than others, and some of it we just can't explain. So here we have a pie chart of the variability decomposition. So, an F-test is about variance, and so some of the variance or the variability in the scores is due to the time points, and that is in this kind of pinkish color here. So this part is due to the time points, and then some of it is due to the within time points, and that's this whole area here. But we can break that down into the subjects, which is in the blue. So some of it's due to just people didn't score higher or lower because of their abilities, or their intelligence, or it could be other reasons as well. So this is the individual differences. And this green part is the error, so this is the unexplained. So the scores are going to differ just due to chance, or just due to maybe that person's mood. There's a lot of things that we're not taking into account. And so that would be the unexplained variance. Okay, and so in a between subjects ANOVA, to get the F, we would do the between variance, or the between MSB, divided by the within. And the within includes both the subjects, the individual differences, and the other error that we can't explain. So in a between subjects ANOVA, we don't have, that person doesn't take the assessment twice, so we can't tell what error, if this error is due to individual differences or to other things. So in between subjects, we just take the between divided by the within. But for a within subjects ANOVA, we kind of just delete the individual differences. And so our F statistics is a little different. We do the between, because that's what, between's always going to be on the top, because we're trying to figure out if there's differences between time points. But we're going to divide by the error, because we know some of the within variance is just due to individual differences. So generally, a within subjects ANOVA is more powerful. Not always, because the degrees of freedom are slightly different for the error. They tend to be a little less for the error than for the within. So not always it's more powerful, but it tends to be more powerful. You know, unless you don't have a lot of individual differences or something like that. But it generally tends to be more powerful. So let's see here. Let's go next slide. So this is the F statistic for the within subjects ANOVA. Again, we have the MS between, the variance between time points, divided by the variance for the error portion. So this is what we are trying to get in the end. So this is our goal here. Let's try to get this F statistic. And remember, we subtracted out the variance due to the individual differences. So the individual differences we want to remove. So our test will be hopefully more powerful.